By the way, it's an interesting fact, if you look at it statistically speaking, that if you have projectiles bouncing together, the small ones and big ones, let's say ping pong balls with different sizes, or billiard balls, you want to call it, with different sizes, that they do exchange energy with one another in the course of random collisions. And it is a very interesting fact that the average effect of this interchange of energies, if the process is happening in an enclosed space where the collisions are taking place randomly and many interactions have a chance to occur, the overall effect is that the ones with less energy get more energy, and the ones with more energy, well, they tend to equalize out so that they all have the same energy on average. For example, in air, you have heavy molecules like oxygen. 16 plus 16 is 32 for a molecular mass of 32. And you have, well, you don't have a heck of a lot of light molecules, but say you do have a small amount of something light, such as helium, atomic weight of 4, much lighter. If these helium starts out with the same speed as an average oxygen molecule, in the course of a lot of collisions, the equalization process works like so. The helium ends up with about 3 times as much velocity on average as the oxygen molecule, because that's enough extra velocity to give it, to equalize the energies. So when there's big things and little things bouncing around together, it's not the momentums that equalize, it's not the velocities, it's the energies that tend to equalize. Now look what that means in terms of your satellite. If you could just get your little projectile off the Earth and realize, so that it was in an orbit around the Sun close to the orbit of the Earth, but let it be an eccentric orbit so that it's crossing the paths of Venus and Mercury and this and that. Now realize Venus and Mercury, all these planets, they're so small relative to the emptiness of space that it's unlikely that you're ever going to have a direct collision. But you will have these interactions, these gravitational interactions where you've got these curved trajectories. But if you want to see what the effect of them is, just think of them as billiard ball interactions. And realize that with billiard balls, with gas molecules or whatever it is, the probable effect of these interactions is to boost the energy of the smaller thing. So the total kinetic energy of the little projectile is really very small just because it's got such a small mass. So on average, the consequence of its meandering about the small orbits and occasionally swinging near Venus and Mercury or whatever it is, the probable effect of that is you're going to be boosting the velocity until you got real high velocity, and you'll probably knock it out of the solar system eventually, or at least pretty far away. And that, I think, is the consequence of these interactions. Someday we're going to analyze that a little more.